So this is an aircraft pressurization trainer. It will simulate how pressurization is achieved on an aircraft, but first I'll point out some components before I get it going. So this is the aircraft altimeter, and next we have our vertical speed indicator. It tells us how fast we're going up and down, and then our vacuum gauge. Down here we have some switches, the master switch, the shutoff valve, the dump switch, which can dump pressure in case of emergencies, and the landing gear safety switch, which tells us if the aircraft is on the ground or in the air. Down here we have the cabin pressure controller, which controls what it feels like, what the pressure feels like inside of the cabin. We have the cabin PSI, the pounds per square inch, along with cabin differential pressure, which is the difference between the outside ambient air and the inside of the cabin. And then we have our vertical speed indicator for the cabin. The portion here represents the pressurized area of the cabin. So we have our safety and outflow valve. They are electro-pneumatically operated. We have the vacuum system that opens and closes the valves as needed. This ducting here represents bleed air from the compressor section of a turbine engine. The bleed air is ducted and directed through to an air cycle machine, which treats the air before it goes through the pressure bulkhead and is used for aircraft pressurization. Before we begin, we have to set our field pressure altitude on the altimeter. So the long hand represents hundreds of feet, the short one represents thousands of feet, and the long one with the triangle on top represents 10,000s of feet. In this case, we're at 150 feet of field pressure altitude. Our altimeter is set and our vertical speed indicator is reading 0 because we're not ascending or descending. We're going to turn on this shutoff valve, which opens the valve and allows air to be pushed through, again simulating engine bleed air, but on reciprocating engine aircraft they can use turbo or superchargers to pressurize along with onboard compressors. Here I'm just setting the cabin pressure controller to above field pressure altitude, and that will allow the chamber to become pressurized. I am turning on our compressed air from the wall, and if we flip our altitude control switch to climb and crack open the altimeter regulator, you'll see the altimeter start to rise along with the vertical speed indicator reading at about a 2, which indicates 2,000 feet per minute. And down here you can see the safety valve is open at this point. And that's because our landing gear safety switch is down, telling it that the aircraft is on the ground. But once we switch it to the up position, that indicates the aircraft's in the air. The safety valve will close and allow the chamber to be pressurized. This is a safety measure on all aircraft to prevent pressurization on the ground. You'll see the cabin differential pressure rising and the PSI of the cabin increasing as well. If we open this altimeter regulator, it increases the speed, so you'll see the vertical speed was way up around 4,000 feet per minute. We want to keep it around 2,000 feet per minute because if we ascend or descend too quickly, it can damage the structure, and it's not all that good for humans either. So we want to keep that right around 2,000. With our safety valve closed, our outflow valve is what's controlling the pressurization. It opens and closes as required to maintain pressurization. We can set the altitude control to descend, and you'll see our altimeter is descending along with the vertical speed indicator below the 0, so that means we're going down, and that's around 1,500. So 1,500 feet per minute. And our outflow valve is open, again controlling the pressurization. And if we turn our landing gear safety switch to the down position, our safety valve will open up and dump the pressure. Now I'm just bringing the trainer back down to field pressure altitude, but there are a couple things I should mention. One being the vertical speed. So you really shouldn't exceed 3,000 feet per minute of ascension or descension on the vertical speed indicator because, again, it can cause structural damage. So around 2,000 feet is good enough. Also, there's two ways to pressurize an aircraft. That's with an external pressurization cart or from the flight deck as a pilot or maintenance tech. And the third thing being related to the cabin differential pressure. Again, that's the difference of pressure between the outside ambient air and the inside of the pressurized area. So down here is the pressurization gauge. You can't see it, but there's a red line on here, and that indicates the maximum differential pressure. So you never want to go beyond that due to structural damage. And the last thing, and arguably the most important, is that there are two modes of aircraft pressurization. The first being constant differential, which maintains a constant difference of pressure between the outside ambient air and the inside of the cabin. So aircraft differential pressure usually ranges between 4 and 8 psi for most aircraft. So the pilot will set the differential pressure to, let's say, 5 psi, and as the aircraft goes through different flight levels and phases of flight, the differential pressure remains at 5 psi, but that means the cabin pressure feels different throughout the flight. And the second mode being isobaric, so that's where the pilot will set the cabin altitude controller to feel like a certain altitude. So let's say 8,000 feet. So they'll set it to 8,000 feet and leave it there, so it'll feel like it's 8,000 feet throughout the entirety of the flight, regardless of flight level or altitude. Here is a real-world example of an outflow and a safety valve. They're essentially identical. They're mounted on the aft pressure bulkhead in the cabin. The outflow valve is used in normal operation in flight, and that controls the amount of air exiting the cabin and controls the pressure of the cabin. The safety valve is activated by a squat switch when weight is on wheels or in an emergency situation where the outflow valve fails. Please note that safety and outflow valves require regular maintenance and especially cleaning, so consult the manufacturer's maintenance manual for the appropriate cleaners to use. So if we make our way into the aft equipment bay, we can access the other side of the pressure bulkhead, where we'll find two air cycle machines, one on either side. So the air cycle machines assist in pressurization along with aircraft climate control. So the ACMs take hot compressor bleed air from the engines, and basically using heat exchangers, compressors, expansion turbines, and water separators all in one unit, it treats the air and makes it suitable for life, and then directs it into the pressure bulkhead to assist with pressurization. There's usually two air cycle machines, one for the cabin and one for the flight deck to keep everyone comfortable. So regular maintenance is required on these. That includes checking ducting, sensors, any leaks. So always consult the maintenance manual, chapter 21, for pressurization and climate control.